Alright, Department of Engineering Fundamental Handbooks, Engineering Symbols and Symbology, Prints and Drawings, Module 5, Logic Diagrams. Table of Contents, List of Figures, List of Tables, Reference, Objectives, Engineering, Logic Diagrams, Introduction, Symbology, Time, Delays, Complex Logic Devices, Summary, Truth Table, Exercise, Truth Table, Reading Logical Diagrams, Example 1, Example 2, and Summary. Figure 1, example of a pump start circuit schematic diagram. Figure 2, example of a pump start circuit logic diagram. And figure 3, a basic logic symbol. Figure 4, convention of depicting multiple inputs. Figure 5, coincidence of the gate. Figure 6, exclusive and inclusive NOR gates. Example 7, type of 1 time delay devices. Figure 8, type 2 time delay devices. Figure 9, type 3 time delay devices. Figure 10, symbols of complex logic devices. Figure 11, truth tables. Figure 12, logic gate status notation. Example 1, example 2. List of figures, list of tables, none. References, dimension, tolerance, graphic symbol, electrical and electronic diagrams, digital troubleshooting, engineering, drawing, design, handbook of logical circuits, design with integrated circuits, naval auxiliary machinery, reading schematic symbols, standard graphic symbols, system summary, Westinghouse, pressurized water reactor valve selection handbook. Terminal objective, give the logic diagram, reading and interpret the diagrams, enable the objective, identify the symbols used on the logic diagram that represent the following components: AND gate, NAND gate, coincidence gate, NOR gate, exclusive OR gate, not on gate or inverted adder, timer, time delay, counter, shifting register, flip-flop, and logic memories. 1, to explain the operation of 3 types of timely delay devices developed in the truth table of the following logic gates: AND gate, AND gate, OR gate, NOT gate, and NAD gate, NOR gate, or exclusive OR gate. And identify the symbols used to denote the logic 1 or higher, or logic 0 or lower, as used in logic diagrams. Give the logic diagram appropriate information to determine the output of each of the component with the logic circuit. This page is intentionally left blank. Engineering logic diagrams identify the symbols used in logic diagrams to represent the following components: the AND gate, the NAD gate, the coincidence gate, OR gate, NOR gate, exclusive OR gate, not gate, or inverted, adder, time delay, counter, shift register, flip and flop, logical memories, introduction. Logic diagrams have many uses in the solid-state industry. They are used with the principle diagram to design solid-state components such as a computer chip. They are used by mathematicians to help solve logical problems called Boolean algebra. However, the principle of the application of the Department of Energy facilitate the ability to present a component with a system operational information. The use of a logic system result with a diagram that allows the user to determine the operation of the given component with the system, the various input and signal changes. To read the interpreted logic diagram, the reader must understand what has each of these specialized symbols represented in the chapter to discuss the common symbols used by logic diagrams. When the master of knowledge should enable the reader to understand the logic diagrams. Facility operators, technical staff, personnel commonly see the logical symbols on the equipment of the diagram. The logical symbol is called gates to depict the operational state of start and stop of the circuits components within the system. The following 2 figures, which use the common facility start and stop pump circuit example that clearly demonstrated the reason learning to read logic diagrams. Figure 1 represents the schematic of a large pump. Figure 2 shows the sum for the appropriate pump circuit using only logic gates. The obvious of the basic logic symbols are understood for figuring out how the pump operates and how it will respond to various combinations of input using a logic diagram. Fast and easy compared with laboriously tracing through relays and contacts of schematic diagrams for sample same information. Figure 1 is an example of a pump start circuit schematic drawing. Where you see the fuses, these different circles, which mean different operating systems. Alright, Figure 2, example of a pump start circuit logic using rectangles and circles to represent symbology, different equipment. There are 3 basic types of logic gates: AND, OR, NOT gates. Each of the gate is simple with the device with the 2 state when on and off the gate is also commonly referred to as a high or low, or 1 or 0, true or false, or where high is equal to 1 or true, or off low is equal to 0, false. The state of the gate is referred to as an output determined by the status for the input with the gates. Each of the gate is responding differently to the various possible combination inputs, specifically these combinations as follows. AND gate provides an output input when all the inputs are on. When one of the inputs are off, the gate output is off, and OR gate provides an output when any one or more inputs are on, and the gate is off only when all inputs are off. NOT gate provides a reversal of an input. The input is on, the output will be off. The input is off, the output will be on. Because the NOT gate is frequently used in conjunction with the AND OR gates, the special symbols have been developed to represent these combinations. The combination of AND gate and NOT gate is called the NAD gate. The combination of an OR gate and a NOT gate is called an OR gate. So your NAD gate is the opposite of the NOT, is the opposite NOT of an AND gate output. It provides an output and except when all the inputs are on. NOR gate is the opposite of an OR gate output that provides an output only when the inputs are off. Illustrate the symbol conversion with the three basic logic gates with the NAD and NOR gates. The IEE Institute of Environmental Engineering X and American National Standard Institute symbols used the most often. However, the symbol conventions are provided in Figure 3 for the information. All right, your AND OR functions. You see these different shapes. The AND OR 3 AND OR 3 has and NAD and 3 have all three parallel lines crossing except of it. Crossing it, the IE and ASI tables also. These symbols are basic logic symbols. Alright, an AND gate with a common variable called the coincidence gate or logic gates are not limited to 2 points. The theoretical, there's no limit to the number of the inputs the gate can have. The number of the inputs increase. The symbol has alterated with accommodated with the increased input. There are two basic ways to show multiple inputs. The Figure 4 demonstrates the method of using an OR gate with example. The symbol is Figure 4 is used extensively with computer logic diagram process and control logic diagrams usually used for the symbology. Figure 2. Figure 4 is a convention of depicting multiple inputs. You see the 4, 5, and 6, 1, 2, and 3. Coincidence of the gate's behalf with like an AND gate with the specific number of the total numbers and input needs to be on the gates and output to be on. The symbol for the coincidence with the gate is shown in Figure 5. The fractional logical symbol that indicates for the AND or gate and the coincidence gate. The numerator of the fraction indicates the number of the inputs. They must be on the gate to be opened. The numerator sets the local total number of the inputs on the gate. So you have your 2 of 3 on the gate, and within the outputs and your inputs and numbers. So you have 2 of 4 coincidence functions, 2 of 3 coincidence functions. The variation and or gate exclusive options, exclusive NOR, exclusive OR, and exclusive NOR symbolize the adding lining on the back of the standard OR NOR gate symbol illustrated in Figure 6. Exclusive OR provides a output when only one input is on. Any of the other combinations result in no output off. Exclusive NOR is an opposite of the exclusive OR gate. The output provides for the output only when the inputs are when all inputs are operating are off. Shows the exclusive NOR and OR with the different inputs of the lines at the back of the gate. Alright, time delays. Logical diagrams are used to represent the start and line, stop of the optical circuit. The diagrams must also symbolize the various timing devices found with the actual circuits. There are 3 major types of timers. There are Type 1 timer delay device, Type 2 delay device, and Type 3 time delay device. Upon receipt of the input signal, the Type 1 time delay is output on the specified period of time. The output will stop off as soon as the input of the signal is removed, illustrated in Figure 7. The symbol at the time of the timer is illustrated in Figure 7. Time 1 time delay device, symbol for the input with the output 4 seconds, or in these different shapes coinciding. The above symbol is used when required to delay the output signal and specified with the delay after the input is applied. So you have your input going through these in their time waves. The two time delay times provides an output and input immediately upon the receive of the input, but the output maintained with the specified period of the time once the input signal has been removed. Figure 8 demonstrates the signal response. Figure 8 illustrates the symbol that denote the time delayer. Alright, use the receipt of input with the 3 times delay device provided with an output signal specified with the time, regardless of the duration. Figure 9 demonstrates the signal response illustrated with the symbol used to denote the timer. This is a 4-second input-output time delay with the different cylinder, the half simultaneous circle, input arrow, output arrow, and their input characteristics, output and time, and input time. Complex logic devices. In addition with the 7 basic logic gates, there are several complexities of logic gates that may be encountered with the use of logic prints. Memory devices. In many circuits, the device can remember the last command, the last position required for the circuit function, and or gates. Memory devices has designed to work on the on and off signals. The 2 input signals of a memory device are called set and reset. The figure 10 shows the common symbols for the use of the memory devices. Alright, this shows the flip results, the SNR, SNF, and FR. Let's start and reset, start and testing reset, adder, half adder, shift, half adder, shift register, SR, retentive memory, 2 rectangulars with 2 lines going in it, 1 out, off return memory, wide into a rectangular return memory, retentive memory with actuating block, L and R, different retentive memory block. Or the flip-flop is the name implying flip-flop device is one or more of its input chains and output chains. The flip-flop is complex circuit constructed for the and or not gates. It may be, but it's used frequently with a complex circuit that has been often own symbology. Figure 10 shows the common symbol for the use of flip-flop. The device also the early exchange flip-flop right here. Flip-flop. FF for flip-flop. Start and reset. The device is occasionally used on the components type of logical diagram principle in solid-state logic diagrams. Binary counters. Several types of binary counters exist, for all of which are constructed flip-flops. The purpose of the counter is to allow the computer to count higher than 1, which is the highest number of the signal flop can be represented by ganging flip-flop. Higher binary numbers can be constructed. Figure 10 illustrates the common symbol used in the binary counter. So you have your binary counter by gaining a flip-flop, gaining something on an input for the flip-flop. You're allowed to each add 1 to each binary counter. The shift register, if stored in the device constructed for flip-flop, is used with the controller to provide with the temporary storing of binary word. The figure 10 shows the common symbol for the shift register. This makes binary word right here. And your half adder is the logical circuit that used by the computer circuit to allow the computer to carry the numbers when it performs mathematical operations. Example, to perform an additional of 9 plus 2, the signal 10 units must be carried from the 1 column to the 10 columns. The figure 10 illustrates the symbol used for the half adder. So this is a maker to make adding up to 10, like a certain number, whole number. Alright, your summary. The information in the information of the chapter is summarized below. Engineering logic diagram. The chapter reviewed in the 7 basic symbols of the logic diagram. Symbols used for 6 or more complex logic devices. 3 types of timely device. Type 1 delays the output signal specified period of time. Type 2 only generates the output for the specified period of time. Type of 3 receipts the input signal triggered this device and output the signal in specified time regardless of the duration of the input. Or your truth table exercise is develop a truth table of the following logical gates and or not gate and add or nor gate exclusive or gate. Identify the symbols using the denote the logic 1 or higher or logic 0 lower. Use the logic diagrams. Give the logic diagram and appropriate information to determine the output of each of the component in the logic circuits. Your truth table to logic gates has only 2 inputs of logic circuit that can be analyzed with one of the 2 gates. It's fairly easy to remember how the specific gate responded to determine the output of the gate. The circuit, by the number of the inputs, the complexity of the circuit grows, it becomes more difficult to determine the output of the gate and circuit. The truth tables illustrated in Figure 11 are the tools designed to help solve the problem. The truth table and the column for each of the input, each of the gate, and the column for the output for each of the column of each gate. The number of the rows needed based on the number of the inputs. Every combination of the input signal was listed, mathematically number the rows to n with numbers of n equals the number of inputs of the truth table on and off status for the input and outputs represented with the zeros and ones, and previously stated 0 are off and 1 is on. Figure 11 showed the truth table. There's several basic logic gates comparable to each gate. The truth table is infinite with a given earlier module. Verify yourself that you're stating same thing. Alright, this shows truth tables. As you can see, your A and B on the input side has zeros, A and B and the output has an F at the AND gate as 0. Also, B has a 1 input, but 0 from the F. Which F is what? I can't remember what that is. Alright. And these are the different combinations. The AND gate and the NOR gate have the same input and except for the output of A. A to B has 0, and except for the A to B has an F, and these are outputs and NOR gates. Alright. Reading logical diagram. When reading a logical print, the reader usually must decide what the input values of each of the gate, but occasionally the printer provided with the information the normal state of each logic gate. This is denoted with the symbol similar to the bistable symbol as shown in Figure 12. Symbol is drawn with the first part of the square wave that indicates the normal state of the gate. The second part of the square wave indicates the off-normal state of the gate. Figure 12 illustrates how the notation is applied. All right, this square curve has a normal high or normal low, and the other square curve to the right has a normal low, normal high. So you have two normal high, normal high, non-normal low. So going into the gate, and then coming out as a normal low and normal high on the field side. Read the logic diagram does not provide the information with the status of the gate, and any more difficult is simply required the reader to choose the initial condition to determine the reason for the circle to modify the input of the need. But the following exercise will illustrate how to read some of the simple logical diagrams. Examples in aiding the understanding the material represented with the module. Practice reading the following logic diagrams, answering the question. The answer on page 18. For the Figure 13, answer the following question. Figure 13 illustrates the logic diagram. Simple fan starting. Safety signal going into 10 minutes with these two gated into a 1-gate of the 2-game automatic signal hand switch placed on the auto position, and then to another while the I can't tell you if they're off or on, but the signal is an on with the hand switch with it starts position with the switch and spring returns. These runs have start and resets, but also these field also leaves it on, but depending on its and or conventional gate. Depends on whether they will be left on or off. Like say if you say it had a dishwasher, but it's on, but the counter clock's on. But like say the counter clock's on your microwave, but you're not running the microwave. That's kind of the same idea between off and on between the logical diagrams. Then there's some questions. Example 2 is the answer to the following question. Illustrate the simple value of the control circuit. The flow control valve with their FCV air operated valve with the controlled flow solenoid valve, which is shown in the de-energizing position. And then there's these rest of the questions, answers. So summary of the important information chapter summarized below. The truth tables exercise some of the normal status of each of the log gate can be symbolized by the use of the symbol similar to be the bistable. The first part of the square wave that indicates the normal state of this gate. Second part of the square wave that indicates the off normal state of the gate. The chapter presented with the truth table, each of the 7 logical gates. The chapter reviewed with the several examples of how to read the logic diagrams and sample pump the valve circuits. Alright, Department of Energy Fundamentals Handbook, Engineering Symbols, Prints and Drawings, and Model 6 Engineering Fabrication, Construction, and Architectural Drawings.